Security ecosystem, a bit more details about that one. So there's a whole landscape of integrations. We're not going to go over every one of them, but let's start with the general request. Infoblox and Cisco ICE. So with Cisco ICE we have a bidirectional integration, so we can deliver information to Cisco ICE and Cisco ICE can deliver information to us. So Cisco ICE provides context to us, who authenticated, for example, so we can add the user information of that user that logged onto the network to the IP address, and also historically report on it so that you know which users belongs to which IP addresses, and we can get that from Cisco ICE. By the way, we can also get that with Microsoft. So that was in 7.2 that we added that, so that you basically can do user identity mapping from reading out the event viewer of a Microsoft AD controller or a Microsoft mail server even. Which helps you identifying the users that use a Mac or an Android phone who will never log on to the domain, but they will always check their email. So basically that's just by setting up that connection, you can gather the user information from Microsoft as well. But that was just on a side note. We can also publish information to the Pixie grid from Cisco. And yeah, that's just contextual information that then Cisco can use further to make its decisions in the security environment or in the NAC solution. For example, we could give them the lease information. You could then start enforcing your NAC on a DHCP level, because if you enforce NAC on DHCP, where you say make an access list or a user authentication on who can actually get an IP address from the DHCP server, that doesn't forbid anybody from giving themselves an IP address and connecting to the network. But if Cisco ICE via the Pixie grid knows that, okay, that IP address on the network was actually not given out by DHCP, so I'm going to quarantine that, you can actually do the enforcement by combining what you know in Cisco ICE and what you know from the DHCP server. And then of course we can also give the DNS firewall events and also the DNS analytics events. So if we see that a client is doing a DNS tunnel, where we'll talk about later in the presentation, then we can tell Cisco ICE, hey, that client is actually doing DNS tunneling, and then that can be quarantined by Cisco ICE or whatever. So the policy remains on the ICE front, but the information, the valuable information about a client doing malware-related queries or DNS tunneling, or maybe even an attack on an advanced DNS protection appliance, can be seen by ICE. A similar integration, and quite new, not even out yet, is the same. It's kind of the same thing, but with ClearPass for your Aruba. So also there we can integrate. We can only provide a DHCP that is in a MAC filter, and ClearPass can add information to the MAC filters. So basically we can assist the Aruba environment in the NAC and the HP as well, of course. Another example of these type of integrations is, for example, with endpoint security, like a Carbon Black. And where can we be valuable there? Well, let's say you have an infected client here, and that client does a malware-related query to Infoblox. Okay, Infoblox knows there's a malware-related query. It comes in the reporting. We can block that query. But what to do further? Go look in the logs to see if that, or at these reports to find out that there are infected devices on the network? No, Infoblox can actually tell Carbon Black server, hey, we saw a query from that client. And then the endpoint security can go investigate that client. It can go log into that client and see what actually happened. If it's somebody who typed the URL and mistyped and Google and some smart hacker registered that mistypo and put something behind it. Okay, no harm done. We know that it was done in a browser, and we know that it was stopped by Infoblox, so it's okay. If it's somebody clicking in a link in an email, same thing. You get a phishing mail, somebody clicks on it, it's stopped by the DNS firewall. Again, no harm done, so Carbon Black has investigated what happened there, and that's finished. But maybe it's an executable. Maybe the device is really infected, has an executable on it that tries to go to a command and control, and the DNS firewall saw that DNS query for that DNS command and control, told Carbon Black, and Carbon Black now sees, okay, that particular executable is trying to go to the internet. And that's something worth investigating further, because that's most likely a malware which is on that machine. So that's how we can work together with these type of endpoint security devices. So if you look at the full portfolio, FireEye we do already a long time. We also started working together with Styx and Taxi. So Styx and Taxi are two protocols which are being developed to have different vendors communicate with each other. We do that today with Threat Connect, which is our first implementation of Styx and Taxi. If I talk about those protocols in Europe, I don't hear many people that heard about it. How's that here in the room? No, nobody heard about Styx and Taxi. So yeah, it will stand or fall with the fact that a lot of vendors will implement it or not. There have been those kind of attempts in the past, like an IFMap as well, where we also participated in, but a lot of those protocols are well intended, but if not enough vendors jump on that boat, then they usually die slowly. So we'll see what Styx and Taxi brings. It looks promising, but so did IFMap, and it didn't do it either. So Carbon Black, we discussed Cisco ICE. What's also coming is integrations with Qualys, which is actually now available since yesterday, and Rapid7, where we can do asset discovery using Infoblox, where Infoblox can basically say that it found new devices on the network, which then by Qualys or Rapid7 can be investigated further. And then other things we're looking at, Intel Security, Force Scout, Tenable, and there's a couple more like Tenium, etc. So if you look at our today's ecosystem strategy and landscape, you see that we're looking both at threat intel from out of our IID acquisition, where we're looking at intel information, gathering that information, where we can bring that to the Infoblox platform as DNS firewall feed. But we also have now our Active Trust platform, where we also get information by working closely together with some institutions in the US, like for example Homeland Security, but also some foreign countries where we get information, and that is put in our Active Trust platform. And Active Trust is basically a service where you can have more intelligence, more information about certain threats. Let's say you have deployed DNS firewall. There is a hit on DNS firewall on a certain URL or a certain IP address, but what does that mean? So you can go to the Active Trust platform, you can type in that URL or type in that IP address, and you get all the contextual information from all those different sources, so that you can see, okay, what is it actually? You can see that there are, for example, other URLs linked to it, which you can then start blocking as well, etc. And this is part of the future. The cloud DNS firewall will also use that information. So we will come soon with an offering where we will offer DNS firewall in the cloud as well. Why is that needed? For roaming users and for customers who don't want to maintain their own DNS firewall, or also if you have a lot of remote sites with local breakouts, then you can use the firewall as a service as well. And then from out of our platform, of course, we can talk with different security vendors on premise, so we can work well together. And actually, in that sense, we're a bit. Somebody internally described it as the Switzerland of security, because a lot of these people are competing to each other, but we can gather the information and we can actually exchange the information. So that's a thing we're looking at as well, how we can be, as being in the center of the core network services, help bring those different parties together and reuse the information that is there. So DNS firewall as a service, not there yet today. So why would you need it? Data center, main offices are protected. You have your firewalls there, but roaming users, remote offices, how are you going to deal with those? Remote offices, are you going to bring them all back to the data center and go to the internet from there? Okay, then you can have locally a DNS firewall. But if you have many of them and they all have local breakouts, Bart would be very happy if you would put a box in each of those sites with DNS firewall on it. But it will be a lot more economical when we come with DNS firewall as a service, that you, for example, if you use the resolver on the router for going to a DNS resolver, you can point the router to the Infoblox DNS firewall as a service and have completely the same DNS firewall policy as you have in your on-prem situation. So DNS firewall as a service, highly efficient and scalable, operates at the control plane and not at the data plane like firewalls and proxies. So that's the on-premise one. Does not require additional infrastructure because you have your DNS servers where you can put it on. You can also prevent DNS tunneling there, and you have fast incident response using your ecosystem. So that's the Infoblox on-prem. As a service, well, you can do both on-prem as off-prem for your roaming users, your branch offices, a common policy management for the whole thing, and so you can deploy physical or virtuals or do software as a service, which can play in your CapEx or your OpEx. So you can mix and match the two together, but use a common policy. So that extends the offering of our DNS firewall. So you could go for a full as a service kind of way, or you can mix and match. Looking at the infrastructure of our DNS firewall as a service, so there's a whole lot of infrastructure in place, which is, by the way, also running on Amazon and is now in test phase, deployed to all the different big regions in the Amazon cloud. So there's in Europe as well. I believe for Europe they're currently in Amsterdam, and as the service grows, we'll expand more to local offices as well. So there's a configuration portal where you can define your security policy. You can have your on-prem Infoblox appliances with DNS firewall, and then basically using the data collector you can send information to the reporting so that you can run reports for your on-prem users and your off-prem users in one report. So you have all the information at hand. You don't need to go locally and then the other and then start combining the information that you get. So you have the full thing. So DNS firewall is there, and we can also offer the threat insight, the anti-tunneling on the DNS firewall as a service, and then use that information to feed our own firewall. And there's of course a DNS infrastructure for the resolving of DNS naming. And then you can point a remote office to it, no client ID, just regular DNS queries being sent. You can have endpoints that are no roaming clients that are just using DNS as well. But you can also install on your endpoints a roaming client, and that makes it easy. When that laptop goes inside the network, outside the network, it can detect if you're behind the hotel Wi-Fi where you first need to log on before you can start using the client. It can detect that you're in the company, so you can start using the local Infoblox, and that will encrypt all the DNS queries that are done towards our infrastructure, so nobody can start snooping to see where your client is going. In the first release, when it comes out, it will be Windows, Mac and Linux, and then later the iPhones and Android will follow as well. So any questions on DNS firewall as a service? Is that something which sounds interesting to you? So it's not there yet, but it's going to be there soon. No?
There's one important thing, that is if you want to use the reporting, or if you want to use DNS firewall for identifying kind of infected computers in the network, you need to implement the DNS firewall on every device which is used as a resolver.
Yes, so you need to be close to the client, and then, yeah, indeed.
That means if you have for reliability implemented an architecture with a lot of small local boxes, so you can have your network up and running all the time, then you need a lot of DNS firewall licenses, and they come with a price too.
Yeah. We understand that, and there's actually a change there which you can maybe talk about.
So DNS firewall, indeed, if you have a lot of resolvers, you need a lot of licenses. There is a stacked pricing, so as soon as you go over 10 or more licenses, the prices will dramatically go down. But more general, you asked another question with respect to our appliances. They all come with DNS and DHCP and IP address management, and you only need some parts of it. We are reviewing completely our portfolio. Today we offer physical and virtual appliances with perpetual licenses on top of it. We are reviewing this because we see also a tendency to go more to virtual and more to cloud. We have the possibility to have a subscription-based license, including the virtual appliance, including the maintenance, on a subscription basis. So this makes that there is no CapEx anymore needed initially when you deploy all your solutions, and you can have it all on a subscription-based license, including the maintenance. And that will help you, of course, reducing the initial CapEx that is necessary to deploy our solution. But on the other hand, we do have volume discounts when you increase the number of appliances to make it more feasible in terms of budget. Yeah. By the way, you have now physical and virtual appliances. You have also cloud appliances in the future now. So independently on what type of appliance that you use on below it, the license for the DNS and DHCP remains the same. So you can switch from physical on-prem to virtual to cloud even, without needing to change always the same appliance. So that's new in our approach, in our go-to-market strategy. So there's a lot of changes, but definitely our Credicom partner can help you in deciding what is best for your environment.
Okay, thank you. So then we come to our exfiltrating data over DNS, which is today a hot topic, because basically if you look at malware, they use DNS as the control plane. If you look at the study of Cisco Security Study 2016, they say that 91.4% of all the malware uses DNS as a control plane. So we think as a DNS company that is where we need to stop that. Stop the DNS or stop the malware at the control plane. We have rich network data and device inventory info, so if you have network insight and all those kind of things, you have a good IPAM, so you know perfectly who's doing the queries, and so we can provide contextual information as well. So if we talk about DNS tunneling or DNS being used by malware, there's actually three things we can talk about. You have, at the one hand, you have DNS infiltration, which is where an infected client tries to get information from outside to the internal network, basically update itself. Malware is being discovered by a virus scanner, and before the virus scanner is updated, we're basically gonna change the malware because we're gonna download over DNS a new version of it, which is not detected by the malware. Or a malware wants to download different components because the person using the malware wants to do some different stuff. For example, this is a downloader script, and if you translate that into base encoded text records, well, basically with four DNS responses, you get that script inside. So the malware, on the other hand, here asks for queries, gets responses, decodes that, and gets back a script inside. So it's very easy to get information from the outside internally, bypassing all firewalls and anything. DNS tunneling then is more a bidirectional communication that is being set up over DNS. Everybody knows what a VPN tunnel is. Basically, you connect to a VPN server and you put your IP packets in that tunnel, and you basically can have a bidirectional communication. You can take over a machine which is in the company. Well, instead of doing that over a VPN server, you can also do that over DNS. So basically, you register a domain name on the internet, you run a server, and from that server you can basically start. So initially you always need to go internally to set up the communication, but once this one does a query, the queries, answers, that's the negotiation of the tunnel. The tunnel is set up, and now the guy here on the other side can start typing on the CLI prompt of this computer and start executing commands, whatever he likes. So basically that's a tunnel where you do a kind of SSH over DNS. Some malwares that use that, for example, FreeBot, Hiloti, Plugix, Morto, there's a whole list of malware that basically, that's the way the attackers get into your network and start playing on your computer. They just tunnel it over DNS. So once you're infected, he does a call to the command and control, which could be stopped by our DNS firewall if you know about it. But if we don't know about it, we need to be able to detect that kind of information. So DNS exfiltration, I think the example was also in the slide deck of Bart. So basically you register a domain name and then you start sending information for it. Here in this simplified example we have again our Mary Smith, and she still has the same social security number as before, but we can start sending that out. But if you see it in real life, you will never see these names and these social security numbers. It will be encrypted, and it will be sent out as queries. And the DNS server internally says like, I'm not authoritative for foo.thief.com, so I'm gonna forward it off to the internet, and from there we go further. Now you could say like, yeah, but we at the company, we have local root. Everything that needs to be resolved internally needs to be there, and otherwise we don't simply resolve the DNS name. If somebody needs to go outside, they need to use the proxy server, and it's the proxy server that does the resolution of the DNS. Well, same thing. Instead of sending the data to the DNS server, the client now does a HTTP request for that domain name that he wants to send out. The web proxy says, I need to resolve that on the internet. And again, you're sending out the data just over the proxy, and it's still simple DNS queries. So if you have your proxy server going out and your DNS internally is completely separated, you still need that protection on the resolver of the proxy server. Okay. These are some examples of malware that uses DNS exfiltration to send out data. Multigrain here is a nice one. Multigrain was discovered on a FireEye by doing the sandboxing by an infected client, and they saw like, okay, we discovered a new malware, it's called Multigrain, and basically at that day people knew about it and other security products could start stopping it. We went back in time to see, because we knew where Multigrain was sending data to, and we found that we were blocking with our DNS analytics tunnels used by Multigrain 2 months before it was discovered by the first analysis tool, which happened to be FireEye. So that's stresses the importance of DNS tunneling. Now, how can you deal with DNS tunneling and how can you discover it? Well, there's actually 2 ways you can deal with it. You can do it signature and volume based, which is basically if you have the known packets like an iodine, which is one of those packets that can be used, you can do it. Or if the volume is high enough, you can see that, okay, this is abnormal DNS traffic because there's too big queries. Then we can detect it. That's something which we can do on our advanced DNS protection appliances. That's our first implementation of tunneling. And that is very useful for example, for ISPs. ISPs, where the roaming clients do not want to log in and start paying roaming costs, the DNS channel is usually open, and they use basically tunnels like an iodine to avoid roaming costs, or in hotels where you can basically do DNS queries but nothing else unless you log on and put your room number. Well, you can basically use DNS to tunnel back to your home connection or whatever, or a service that offers it, and you can surf for free. Well, you have enough on the known packets and the volume to detect that, so for a service provider this is a good solution. But what we saw immediately after is, yeah, but this doesn't cover the whole thing, because if you go low and slow under the radar and you don't use the known packets, well, you don't have a signature for it and you don't see enough volume at the same time to detect it, well, then it just goes out. And the only way you can solve that, and there's no next-gen firewall that today can do that, is when you start streaming analytics. And streaming analytics means when you look at queries that go to a certain domain name external, you're going to look for a longer period of time to that information. You look at entropy, lexical, n-gram, the frequency of the packets, the size, and you put a mathematical model behind it. And basically, simplify that mathematical model is something like this. For example, entropy is the requests containing lots of information. Well, if it contains lots of information, it's more likely that it's information that's being sent out than it's a query, because a regular query is www. a domain name. If it is, hey, this is a piece of information that I want to send out whatever.com, yeah, then it's more likely that it's going to be DNS tunneling. Frequency and the size, if the packets are bigger and more often, then yeah, it's more likely that there is tunneling going on. Does it more look like something encoded, or does it more look like Danish or English or French language or whatever? Well, if it's an encoded thing, then it's more likely to be tunneling than not. Does it more look like a language? Yeah, then it's probably less likely that it's tunneling, because clear text tunneling is not very often used. And then some proprietary methods where we look at to false positive mitigation, etc. Did you know that a lot of virus scanners, probably your virus scanner, is using DNS tunneling to check if certain executables are considered vulnerable or not? So they're basically sending out information via DNS and getting responses to do that communication. Anybody knew about that? So for the ones we know, the virus scanners that use that, we say like, okay, this is the virus scanner, so that's not a problem, that's a false positive. We're not going to consider that as DNS tunneling. Although in fact it is DNS tunneling, because the virus scanner is basically using DNS tunneling to go out. Why do they do it? Well, because it's the easiest way to go through all the firewalls. You basically, they're using the same methods that the criminals and the hackers are using. They're just using DNS tunneling to check information. But that one is of course good. And if you add all that information together, then at a certain time you can say, okay, this is DNS tunneling. We're gonna stop it. So if it's the known packets, we can stop it immediately. If it's very volumetric, we can stop it quite quickly as well, just as your firewall. If it's low and slow under the radar, we'll look at it over a longer time, and then we can basically stop it. And low and slow is not actually that slow, because we're now gonna go to a live demo where we can demonstrate how that works. But first, are there any questions on tunneling, or is this a concern for anybody? Is this something you were aware of that it existed, or not really?
It's not a concern if you don't know it exists.
Yeah, so you were not aware of that it existed.
Maybe
Yeah.
they're concerned now.
Yeah, okay. So who's in the not aware group? Okay, so most of the people are well educated, they knew about it, or too lazy to put their hand up.
Do you have any plan to offer this as a cloud service?
Yes, yes. So when we go back to our firewall as a service slide, so that's the infrastructure. Threat inside here, analyze all the DNS packets. So that's where we can do it. So the threat inside is our DNS tunneling. So if you use the firewall as a service, the threat inside will be there as well.
What I mean is that I would happily provide you as a trusted provider with a feed of all DNS requests in our network. And I mean, that's a whole big data thing. I mean, if you have tens of thousands of feeds from all your customers, even slow, low volume traffic would easily become detectable by you.
Correct.
You can see the patterns that we can't see if we implement this on premise.
Yep.
So I provide you with a feed, and you do the detection, and then as part of the normal DNS firewall, if you find out that a domain is used for malicious activities, DNS tunneling, then you simply block it.
We can block it for everybody.
A service you could offer?
Yes, that's exactly the point of that service that will be there soon. So I think was January time frame or
Early next year, yes.
early next year. Early next year we're going to be able to offer that. Yeah. Okay. Okay. So let's go to our demo.
Eric, the analytics,
Yeah.
how well is it dealing with different languages?
It has quite some different dictionaries for quite a lot of languages, and it's not only looking at all the words, so it's not a pure dictionary, but it's also looking that there are some algorithms that can define if somebody is more like a word. Actually, intuitively, you can see the same. If you saw that encrypted text for the script, all those characters, you don't know all the languages in the world, but you saw immediately that that was not a language, right? So because in most common languages, there are certain orders of letters and words that, and there are existing models that can basically determine that, and that's the kind of stuff that we're using. So it's not pure dictionary looking for Danish words and Dutch words and English
But then
words.
again, it could have been a Welsh word.
Yeah, so the Welsh might be triggered, and Finnish as well. Yeah, indeed. So some languages will be more difficult, and if you look at some of the like Chinese, they are translated into ASCII format, and if you take these Chinese letters that are translated into ASCII format, it also looks like this is something. It's almost like they're encrypting their letters. So I don't know how they deal with all those things in detail, but I know there is certain analytics that can discover if somebody looks more like a language. And then there's of course the obvious given words that are taken into account, like FTP, WW, and so on. We know that that's a very common thing to do, of course. Okay, let's see. Okay, so we are here in. So what we have here is I have a virtual machine running on my machine, so I could go into a vCenter, and from that vCenter I can log into a Linux machine. So we have the Mac, we have the virtual machine running Windows, and then we have here in the vCenter we have basically our Linux machine that is running in my office. Why we need to do such a complicated structure? Because I have DNS analytics running in the office and not on my laptop. This is a portal, the data exfiltration demo portal, and if you're interested, we can work together with Credicom to get you an access to it, so you can do your own test on your network if you can send out files or not. Of course, be careful what you send out, because it's going to be posted on that portal. So I did a test earlier here today. Basically, this one I sent when we came in using the Wi-Fi here. I don't know if the Wi-Fi here is behind a firewall or not. No, it is. So that went through. So that's the firewall didn't see it, but maybe it's a guest VLAN, so maybe you're not really detecting it. But even if it was your next-gen firewall with all the inspection enabled, I'm quite sure it went through as well, because we've presented that at some of our customers where they say like, yeah, but we have this and this in place, and then we start up that portal and it just goes through. So if you don't believe me, you can try it yourself in your environment as well. And then the second one I launched from this machine, and then you see that it's less. But let's do it live now. So there's a couple things you can do here on this tool. So there's a DNS text decoder where you can basically type in some text to test, and that basically translates this to an encrypted query which goes to dexdemo.net. So if you want to cheat, you can block dexdemo.net on your firewall, and then you can say we don't get through with the DNS tunneling, but basically. But any other domain name then would still work, of course. So if I do an NS lookup for this domain name, then this text will go on the other side, but it's a Linux machine, so let's then it becomes host. So I just copy paste this text, so that's the simple example. And here we paste it, so we do a lookup, and we got an NX domain. Okay, yeah, that's good, because there's no answer to it. But then we go to the transferred files and method and type in some text to test. See, so it just, the query went through and the information is decoded on the other side. So we basically do the same thing as a malware would do, and we do it. But then you can say like, yeah, then you need to type a lot of text. So we can do it with a whole file as well. So we can here type a file name, and we can say what the IP address is where we want to send it to. And I have a file name called secure.txt, and now I'm gonna send it to a particular DNS server, 10.129.37.7, which is my appliance. But then here we're gonna first turn off our. So this is the DNS analytics running on Infoblox. So I'm going to stop it now, so it's not running. Hope there's no colleague at the same time doing a test in the opposite way, because then it won't succeed for you. So let's stop the service here. Okay, so it's not running, so we go back to our Linux machine. And here I can say generate script. And this explains kind of how easy it is to build a script that does DNS exfiltration on both a Linux machine as a Windows machine. Maybe I can make it a little bigger. Can I? No, doesn't make it bigger within the screen. So this is a a Unix shell script that basically looks for my file secure.txt and then cuts it up and does host queries to a certain subdomain towards that DNS server. If you want the same for a Windows machine, this is what you can copy paste in a PowerShell. So if you go to PowerShell and you copy paste, this is actually a pure data exfiltration script. This is now a text file, but you can just as well use a JPEG or any other binary file, a SAM database maybe. SAM database file is interesting to send out, so you can get the passwords. And that's just going out over DNS. So let's now do this for the Linux way. So I copy paste this one, copy, and we go here. And then we paste it, enter, and now it starts cutting that text into pieces, and it's going out. And basically that's my data exfiltration. So that text file, maybe I can open it up here. Vi secure.txt. Credicom flight 2, my text, which goes a bit further. If we go down, and it ends with Credicom flight 2. Flight 1 was my test from this morning. So now we go to the demo portal here. Well, let's not do it here in the local machine. Let's do it here over the Wi-Fi. So I can go here to that DEX site as well. So now I'm not in my system anymore. So I'm on the outside of the network. And we go to our data exfiltration, transferred files, and here is our secure.txt file, and you see it's completely passed through. So we send it to DNS from my office in Antwerp to here on the Wi-Fi. Now let's do the same, but now let's go to our Infoblox appliance and start the analytics. So yes, restart the service. Oops. And we're sending again our queries. Of course, these queries keep being sent. My script is not going to stop sending those queries, but what's important is what we get on the other side. So we have here now 4355 packets, and are we finished? Yeah, so we're finished. Now we open up this secure.txt file, and then we see that we have our test with analytics 42, but in the end it stopped. Which means, of course, this part went out. But what's better? To send out this part and then stop and get a warning that there is DNS tunneling going on, that you know where it's going and which client it's doing, or you keep doing this for months and months and months and months. So that's how you deal with it. The reason I use the text is for a demo purpose it's quicker, because if you use a binary file it becomes very quickly very large, and also to see where it stopped, because if you do it with a picture, yeah, okay, you see you can't open the picture, but how much got through you don't know. So, but we can do it with a picture as well if you like. And everybody's scared now. You have a question?
How much delay does it introduce in the general DNS functionality?
Not much. So it's doing that analytics in the background. So it's processing its queries. It's not going to stop, analyze the complete packet, and then do the DNS query. There is a short delay, but no user is gonna notice it. Well, the user is gonna notice it when his tunnel stops, of course, if he's doing it himself. If it's an infected device, the user is not going to notice that it stops, but the malware is not going to go out anymore. But then, of course, it becomes important to find out which client it is and to find out why it's doing DNS tunneling, so that you can stop it. Because if they go off-prem and you only have it on-prem, then of course the DNS tunneling can continue when they just connect it to the internet outside of the office. Unless, of course, you also use the DNS firewall as a service in the future. So 91% of all the malware is using this to get data out.
How much? 90?
91%, according to Cisco, not us. No.
20 minutes left?
20 minutes left. There was a request for advanced DNS protection, so we could go to a presentation on that one, if you like. So this is about DNS attacks against the DNS infrastructure itself. So if we talk about DNS firewall and DNS tunneling, that's to protect the client who uses the DNS server. Advanced DNS protection is more to protect the DNS server itself against all kind of DNS-based attacks, both volumetric and non-volumetric. Although it also can handle some of the DNS tunneling, but then more focused for the ISPs. The volumetric and the ones trying to avoid roaming costs, etc. So why is it important? DNS is an ideal target for attacks, as we saw last Friday. It will bring down the DIN DNS service, and there is no, what was it, Netflix, Spotify, Twitter. So basically, by bringing down one DNS server, you bring down everything my daughter would ever do on the internet. Because that's the kind of things she's doing. And for her, it was a difficult evening, of course. So DNS, cornerstone of the internet, used by everything. If you can bring down DNS, then basically you bring down any service that is being used, because nobody types in IP addresses. How many IP addresses you know from the internet by heart?
4 billion.
You know them all? Yeah.
Yeah,
But what they are? But you don't know what they are? Oh, okay. I know 8888 and 8844, that are the DNS servers from Google. I know that the IPv6 address of Facebook, at least their network range, is Facebook spelled with a C in the end, because K is not a hexadecimal. But that's about it, what I know about internet addresses on the internet. So everybody uses DNS to go anywhere. And when DNS was invented, basically it was just a couple of universities who said like, hey, we're tired of updating all those host files because it's becoming too many machines. Let's build a protocol to look up things, and then basically they didn't have security in mind. It was just a service, and DNS hasn't changed that much since, so that makes it the ideal target. The reason they're going to DNS is because everybody invests heavily in protecting that web server, and you have all those products to defend that web server, but if you go attack the DNS server, it's just as effective. So 216% of the rise in DNS attacks year over year. This is a bit older presentation, but it was the same last year. And 47% of all the DDoS attacks are, according to this slide, DNS based. Well, we can adjust that. This slide is from 2014. In the meantime, it's become 73%. So almost all the DDoS attacks on the internet are DNS based. So that's why you need to do something about Yeah, the reasons: easy to spoof, asymmetric amplification, easy to do amplification. Certainly if you sign your zone with DNSSEC, then you can send a small query to your DNS server and get a big answer, and then send that answer somebody else. And then you can basically have a huge amplification by sending out 1 gig of traffic. You can basically send 40 gigs to your attacker. And if you look at the attack from last Friday, they were talking about 600 gigabytes per second, which is huge. And a high value target, of course. The next one is a marketing slide. Let's skip this one. Yeah, these are older examples. It's a bit of an old slide deck I took. So distributed reflection attack, what actually happens is an attacker goes query with spoofed addresses to open recursive servers on the internet, and then those get amplified by those recursive servers and sent out. That's not what they did in the DNS server attack. There basically what they did is let the fridges and the robots and what was it, child robots and so on, they were doing the queries. And if you have enough of those, then you basically have all the power you need. And that's a bit of a tricky point, because all those devices, you don't have a login to it. You can't go patch them and secure them. How many of you patched their fridge? Not many, I think. So maybe your fridge is connected to the internet, maybe not. You might not even know. There's some equipment out there that just find if there is a Wi-Fi, and then they use it to communicate. So you have no control over these things, which is also a good thing if you talk about solutions like a DNS firewall and a DNS tunneling, because if you can't control the endpoint, well, you need to do it on the traffic itself. So you need to look there. But now back to attacking DNS itself. There's all kind of different attacks. Reflection attack we just talked about. Amplification is just make it bigger by bigger packets. You can basically also do a TCP, UDP or ICMP flood on a DNS server. It's not even DNS protocol, but if you send packets enough, the DNS server is going down. Maybe they're using BGP Anycast. Well, let's try attack the BGP. So all those kind of things we need to protect in the appliance, not only the DNS traffic, also other traffic. NX domain attacks, slow drip attacks. Anybody know what a slow drip attack is? So basically it's a kind of denial of service attack which is harder to discover to your typical DDoS solution. If you look at an arbor, it looks at the volume that is coming in, and then basically if it sees enough volume, it can take an action. A slow drip attack is not that big in volume, but is exhausting anyway the resources of a DNS server. Why? Because for example, they register a domain name on the internet, they run it on a DNS server that deliberately answers slow, and then they start asking questions for that domain name. What happens is the DNS server sends out the query, waits for the response, gets the next one in, waits for the response. So you can build that queue of concurrent waiting DNS queries to its maximum, and then the server collapses. And that's something which is difficult for a solution like an Arbor to do, because they can only look at the pure volumetric DDoS attacks. But also non-volumetric attacks, DNS hijacking, try to spoof an address, ask for the bank name, and then try to give the answer faster than the DNS server of the bank, and then maybe combine that with an attack on the DNS server of the bank so that he doesn't answer too quickly, and then basically whoever asks that DNS server for the bank will get your IP address, which is where you can play a man in the middle attack instead of the IP address of the one you're sending it to. DNS-based exploits. There's a vulnerability in bind. Okay, people didn't patch their DNS server yet, so basically we can exploit that vulnerability. Stop those protocol anomalies. do something where DNS is not intended for, reconnaissance attack, to figure out what kind of DNS server it is to do the other ones. So both volumetric and non-volumetric things need to be detected. So what can advanced DNS protection offer there? So basically protection against widest range of these kind of DNS attacks, and also very important, the threat adapt technology. So you have signatures in that ADP appliance that can be updated. If the hackers tomorrow find something new, or tomorrow there is a vulnerability coming out online and people don't want to install their updates immediately, then basically you can stop it on that NIC card, which is in that advanced DNS protection appliance. And quick deployment. If you look at corporate environment, then the standard settings are really usually very good. If you look at ISPs, they sometimes need to fine-tune some of the rules depending on how they use them and where they use them. So it's a specific type of appliances, the PT appliances. So you have the 1400, 2200 and 4000. And they have a special NIC card on board, Cavium card, which is programmed to stop these kind of DNS attacks. So they recognize the attack and they stop it on the line card itself at line speed before the DNS traffic is handed off to the DNS engine running on the same machine. So it's not something you put in front of your DNS server, it's the DNS server itself, but it's handled in hardware. We're now also looking at virtualizing this, because if you look at elastic scaling and spinning up more machines in the cloud, well, then obviously we need to be able to give that same kind of protection virtually as well. And then the advanced protection, which gives that you get the necessary updates. So it's fully integrated in the grid. It's just a member like any other in the grid. And the blue legitimate traffic is going to the DNS engine on that machine, and the red is being stopped on the NIC card. And then of course via your free reporting server you can get the necessary reporting on that as well. And then, yeah, so legitimate traffic goes through, attack information is being stopped. So you can see reports, you can see when you were under attack, how heavy these attacks were, what type of attack was it, where it was coming from, how many packets we stopped, dropped, and so on. So you can have full visibility on what's going on. How are they being deployed? Advanced DNS protection in corporate environment is usually used for protecting the external facing DNS servers, because they are the ones that can be attacked and they are the ones that are reachable from the outside. If you look at school environments and high-tech environments, there sometimes you need internally also this kind of protection if you don't trust the people that are on your network. Or ISPs are very often going to use those for their recursive caching devices that are used by their clients, because they are very often under attack. Here in the picture you see them behind the firewall in the DMZ. There are a lot of our customers that deploy them next to the firewall. And that's also what I recommend to do. Why? Because if you have a heavy attack on your DNS server, the first one probably to collapse is that general purpose firewall that needs to deal with all the protocols and not just with DNS. So it's my opinion, it's better to put it next to it. Sometimes there are companies, they say like, yeah, but our policy is it needs to be behind the firewall, and then they get a heavy attack, the firewall collapses, and then they put it outside anyway. So best to do it from the start. So that's the slides about the advanced DNS protection.